Hey, Samer, I've been buried in the research for so long here. I'm just sort of curious as to what's happening on the tech transfer front here at Carnations.
Recently, we started prototyping some of the work that we've done on the GPS INS detection, the patent pending one that's with the help of IIT Kaplan Institute or support of Air Force Research Lab to make it as a software library. Now we're trying to make it on the embedded system. So we kind of acquired some of the components, hardware components here, and we're using a computation module such that we can maybe working on putting this together on this small compact form factor. And this will act as a spoofing detection and potentially even mitigation, meaning that if the spoofing is on the subset of the signals, that it could still provide positioning with the unspoofed signals. We have conducted customer discovery with the help of Chicago Booth School of Business, where we interviewed different stakeholders in different industry sectors. And out of that scope, it seems like UAV or small drones are potential customers for this prototype. Avionics manufacturers are a little bit harder because there's a process of certification that might not be suitable, at least for the hardware we're building. But we definitely are open to collaboration with industrial partners, and we're trying to reach out to see if that works out. In addition, also, we're trying to reach out to the ground vehicle sector to see if also this would be of interest for them, and we're still working on that. So we're still in the middle of the process of customer discovery.
So this is a device that has a lot of potential applications in terms of transportation.
Definitely, because GPS is not only used in one sector. It's all over. It's used for ground transportation, maritime, aviation. We are also even trying to expand into timing applications as well, just in case it's needed for infrastructure, like power grids or financial transactions.
So in terms of, say, national security and all this, I think it sounds like this product is really timely, because it seems that any nefarious actor who can, say, produce a counterfeit signal and try to lead astray, some vehicle and with people in it, could be mitigated.
Yeah, definitely, especially that although right now what we see is that these spoofing events, especially spoofing events and jamming events happening in conflict zones, the technology to reproduce that on a smaller scale is already available. So this is a low-cost device that you could build kind of from certain components online with even explanations of how to build it, the software to put it there. And this would allow you to spoof or jam devices in a relatively small range, but it could have done enough damage to ground transportation, to users. You could even think of certain applications, like phone applications, like ride sharing or similar applications, or delivery, package delivery, where someone with a device like that could really, have a big impact on different users. So I believe it's just a matter of time before this becomes more common and people would just start, using it for different reasons. Some might have curiosity, some might use it for nefarious reasons. But if we have a protection for that, and if we can toughen GPS such that such a device will not cause what's important, like or have a safety of life to be impacted by that, I think that's definitely is a right path that we should follow.
Yeah, you bring up an interesting point with these networked systems. Also, it seems that one intruder, could produce a cascading set of failures, here, and that even if any potential entry point would be protected, it would actually protect the entire network thereafter, keep it from getting infected. So one small device like this, equipped in each car, would be pretty cool.
Definitely. And again, remember that this is just a prototype. I think this could be even miniaturized much more than that. Once we provide a validation for our prototype, we're trying to use if they get the permission, the VDTI infrastructure to test some of the prototypes that we're building. We're also trying to participate in some of the events where they do the open spoofing, also to do further testing for our prototype.
Excellent. Thank you.
One of the projects for anti-spoofing that we're working on, although we have also a couple other ideas we're working on, I'm curious of what the status of anti-jamming technologies that we're working on under CARNATIONS.
Yeah, it's a good question. We talk a lot about spoofing because it's the more dangerous of the two things. If somebody doesn't know that they're being manipulated, that can put you in a bad situation. On the jamming side, which is actually much more common, the GPS and GNSS signals are very weak, and all it would take is a small device that you could basically knock out an entire city, and obviously providing a disruption of service like that in a place that's highly dependent on it is obviously going to be a huge problem. Okay, and we're only going to get more dependent on it in the future with the projected connected autonomous vehicles and the like. Right now, if a car is see an autonomous car is subjected to some sort of form of jamming, and we don't have protection against it, you'd basically have to pull over. All the vehicles would have to stop. Okay, and we need to provide a defense against that. Okay, so the type of technologies that we're using here, there are augmentation, that is combining GPS and GNSS with other sensors that are complementary. For example, inertial navigation sensors, including gyroscopes and accelerometers, which are immune to the jamming, but they can't do the job by themselves. Also, electro-optical systems like laser scanners. That's another thing that we'd be able to use. You think in urban canyons, for example, there's sort of this natural denial of service that you might have where satellite signals are just blocked. We might not have a lot, or we go under a bridge. So these types of technologies are needed anyway. And we're trying to leverage them in creative ways to help mitigate the jamming problem, as well.
So it's interesting that you bring up the network nature of the future of autonomous cars. And you did touch on the effect of jamming on this network. I'm curious now, how do you see the effect of spoofing on this?
That's an open question, and so it really depends on how much information is passed and how much between vehicles and infrastructure and how much of it is used. If we think of an individual car, for example, if I am spoofed and I'm a driver, okay, I'm physically driving the car, and I can see what's going on. If I end up at a restaurant that's not the one I want to go to, I'll say, well, that's a lousy navigation system, but it's not going to put me in any danger. Now, if I suppose I connect that navigation system into the control system of the vehicle, and I'm sitting in the back seat or reading a book or whatever, that's a whole different story, an entirely different story. So that autonomy, or that desire to have autonomy, is what puts us in a situation where the spoofing is extremely dangerous. Okay, and so that's just for one single vehicle. You could drive into the middle of an intersection and get T-boned, or you could drive off the road. Okay, but let's suppose these vehicles are networked together, which people are envisioning connected autonomous vehicles. This is the future of transportation, so to speak, and they're networked together via static infrastructure or directly between vehicles. And if one vehicle is subject to a counterfeit signal, and it is not only personally affected, but is distributing that information across to other vehicles in the network. Okay, and so what happens? Well, we don't know. It really depends on how the system is set up. And this is part of our research as well. We need to robustify the other vehicles to keep them from being infected, by the vehicle that is initially targeted. Obviously, it'd be nice for that initial vehicle to defend itself before it sends that bad information, but as a second layer, it must be that we are able to maybe even reverse the damage by having the other vehicles who are now in possession of the first vehicle's information help that first vehicle come to its senses and say, no, it cannot be that you are there, given that I know where I am.
That's really interesting, and you brought up the question of urban canyon, And I know that we've done, even before Carnations, but now we're continuing with Carnations, we've done some research on navigation of cars in urban canyons. And can you comment on how Carnations is even addressing some of the problems that we could see there, specifically since we're talking about resiliency there, whether we're only focusing on resiliency of GPS and GNSS or other sensors as well?
Well, other sensors as well, of course, because when we're getting into a situation where, GNSS is denied and we still have to have position, navigation, and timing, that we have to protect as well. It's just that the GNSS and GPS is the most ubiquitous, but it is restricted to relatively open skies. So now we're getting into urban areas, where we have urban canyons, bridges, tunnels, and things blocking things. And so we have to say, okay, we need to know where we are. Okay, and we take, say, for example, laser scanners as a typical example that we work with. Vision is another, application. Vision is difficult, from the point of view of integrity because there's so much information coming in. So we're right now focusing a little bit more on the laser type stuff. But you have to do distance measurements off of known objects, buildings, poles, and things that are mapped in the environment in order for you to place yourself, on that street. And so if there's any disruption to that environment, movement of objects, which happens all the time in a city, it will affect us, and if there's deliberate, movements of things, that's a spoofing, situation. If there's removal of landmarks that we want to be using, this is going to affect continuity and be equivalent to sort of a jamming, situation. So these situations are quite difficult. There are other technologies that are possible, including radio frequency ID tags that are used, to identify containers and things like that, and their locations and things. Those suffer from signals bouncing, off of buildings and the ground and all that. So it's very difficult to use in a cluttered urban environment for ranging. So these are open questions, and we have an active research area right now in trying to determine what are the threats associated with spoofing of laser scanners and how we understand those threats and develop mitigations against them.
So I think what's exciting about Carnation is that we're not only looking at one aspect, which is spoofing detection and mitigation, but we're also trying to cover other aspects, including situational awareness. So I am aware of other groups and Carnations that are doing some of that work. Do you know where they are now? What do we achieved on that front?
Yeah, that's an interesting one. So that's an area of active research at Virginia Tech. The idea of not just identifying that we're in a situation where we're being jammed or spoofed, but also localizing and determining where it's coming from so that the offender can be caught. Okay, so these types of technologies are important as well because they're deterrents. And the strategy, for example, might be that you have a moving vehicle with a single antenna and is kind of able to track the direction, at a given instant, where it might be coming from. And then as it moves, you might be able to triangulate where the distance as well as the direction. Or using multiple antennas as well on the same platform, we'll be able to do that. And this is one of the principles behind these controlled reception pattern antennas, which can sense where the biggest signal power, jamming power is coming from, and basically point an antenna null in that direction, to minimize the gain in that direction.
So in this case, it says if Carnations covers all three aspects of protect, toughen, and augment.
That's correct.
GNSS has.
Yeah.
And the protect side here is if you have the situational awareness and you know the source of the signal, you could inform law enforcement such that they could at least react faster to the attacker.
Yeah, that's exactly the idea, right? So the defenses come first, where the augmentation and the to help us understand, that we're being affected, and that we need to defend ourselves first. Okay, that's the thing, or else people are gonna die. And then afterward, it would be nice to be able to continue operating, even in those situations. But ultimately, we need to make sure that people like that are not even tempted to do something like that. So the isolation of the perpetrators who are doing this, or even in some cases, it's inadvertent. It's just a signal leaking, out of a lab or out of a demonstration facility at a conference or something like that. That also needs to be located and shut down as soon as possible. But the first step is location.
So Carnation is not only doing, things just for research purposes. There is a tangible outcome for, globally, but also for the United States. Don't you agree with that?
That's really a great question. I mean, the research we're doing here directly supports the resilience of the U.S. transportation infrastructure. Positioning and timing are foundation. Okay, everything from autonomous vehicles, air traffic management relies on them. Okay, by making those systems more robust and secure, we're addressing national security and transportation safety concerns head on. Okay, at the same time, we're building a skilled technical workforce that can carry this momentum forward. So that dual focus, technology and talent, is what makes the impact long-lasting.